Using Riemann sums, evaluate integral of x cubed minus 5x dx from 0 to 3. Now, because we are using Riemann sums, then we need to find delta x. And delta x is b minus a over n. Now, b is the upper limit, which is 3. And then a is the lower limit, which is 0, divided by n. So delta x is equal to 3 over n. Now, the next thing we need to find is xi. Xi is a plus I delta x. And this is equal to a is the lower limit, and the lower limit is 0. So 0 plus I, then times delta x. Delta x is 3 divided by n. So times 3 divided by n. And this is equal to 3 over n I. So let's go ahead and write the formula for limit. But we know that the definition for I is that I is equal to 1, 2, 3, up to the number n. So from Riemann sums, we know that integral from a to b of f of x dx is equal to limit as n approaches infinity of sum of I equals 1 to n of the function f of xi delta xi. So this is the definition for the Riemann sums. So what this means is that integral from 0 to 3 of x cubed minus 5x dx is equal to limit as n approaches infinity, then sum of f of xi. So that means wherever we see x in this integral, we should put 3 over n I in it. So the first one is x cubed, that is into bracket 3 over n I cubed, then minus 5x, which is 5 times 3 over n I, then delta xi. But we know that delta xi is delta x. There's a mistake here. This is delta x. So delta x is 3 over n, so times 3 over n. So this is how it turns out to be. So now let's focus on this. So this is equal to limit as n approaches infinity. Now we want to expand this. So this is equal to sum. So this sum is I equals 1 to n. So sum from I equals 1 to n of 3 cubed is 27 over n cubed, then I cubed minus 5 times 3 is 15, 15 over n I, then times 3 over n. So this is equal to, now I want to break this, sorry, there is no equal to here, so it's limit. I want to break this limit, so this is equal to limit as n approaches infinity of, I want to pull this constant out, which is 27 over n cubed. So 27 over n cubed, then sum from I equals 1 to n of I cubed, then minus limit as n approaches infinity. Sorry, I made a mistake here. So all of this is times 3 over n. So let me bring 3 over n here. So here too will be 3 over n times 15 over n. Then sum of I equals 1 to n of I. So this one is I. Now this is equal to, so 3 times 27 is 81. So this is equal to limit as n approaches infinity of 81 over n times n cubed is n exponent 4. Sum of I equals 1 to n of I cubed. Then minus, it is limit as n approaches infinity 45 over n squared, then times sum of I equals 1 to n of I. Now, remember that sum of I equals 1 to n of I is equal to n times n plus 1 divided by 2. Then sum of I equals 1 to n of I cube is equal to n squared times n plus 1 squared, all divided by 4. So if we expand this is equal to n squared times n plus 1 squared is n squared plus 2n plus 1, all divided by 4. And this is equal to n times n is n exponent 4, then plus 2n cubed plus n squared divided by 4. So that is sum from I equals 1 to n of I cube. So we are going to replace all of that here. So this is equal to limit as n approaches infinity of 81 over n exponent 4, then times, now all of this is n exponent 4 plus 2n cubed plus n squared divided by 4, then minus 45 over n squared, then times, this one is, if we expand this is n squared plus n divided by 2. So all of this will be n squared plus n divided by 2. So from the previous step, we reach limit as n approaches infinity of 81 over 4 times n exponent 4 divided by n exponent 4 plus 2n cubed divided by n exponent 4 plus n squared divided by n exponent 4 minus limit as n approaches infinity 45 over 2 times n exponent 2 divided by n exponent 2 plus n divided by n exponent 2. So this is equal to limit as n approaches infinity. Now 81 over 4, then n exponent 4 divided by n exponent 4 is 1, plus 2n exponent 3 divided by n exponent 4 is 2 over n, plus n exponent 2 divided by n exponent 4 is 1 divided by n exponent 2. Then minus limit as n approaches infinity 45 over 2, then times n exponent 2 divided by n exponent 2 is 1, plus n divided by n exponent 2 is 1 divided by n. Now if we apply the limit, so this becomes 81 over 4. Now we are bringing that out. Limit as n approaches infinity of 1 is 1, plus limit as n approaches infinity of 2 over n is 0, plus limit as n approaches infinity of 1 over n squared is also 0, minus, I'm bringing 45 over 2 out. Limit as n approaches infinity of 1 is 1, plus limit as n approaches infinity of 1 over n is 0. So at the end of the day, we will now get 81 over 4 minus 45 over 2. And we can find the LCM. So here is 4. So 4 divided by 4 is 1. 1 times 81 is 81, minus 4 divided by 2 is 2. 2 times 45 is 90. So 81 minus 90 is minus 9 divided by 4. And minus 9 divided by 4 is minus 2.25. Now, we could also use the ordinary integral to compare the result. So this is integral of 0 to 3 of x cubed minus 5x dx. So this is equal to, if you integrate x cubed, you get 1 over 4x exponent 4 minus, if you integrate 5x, it becomes 5 over 2 x exponent 2, evaluated as 0 and 3. So this is equal to 1 over 4 times 3 exponent 4 minus 5 over 2 times 3 exponent 3. All of this minus 0, because if you put 0 here, it will throw out 0. So this is equal to 1 over 4 times 3 exponent 4 is 81. then minus 5 over 2 times 3 exponent 3 is 9. Now, this becomes 81 over 4 minus 5 times 9 is 45 over 2. So you see that at the end of the day, we are back to this place. So if you do this, the answer is also minus 2.25. So whether you use Riemann sums or you use the ordinary integrals, you are supposed to arrive at the same answer.